Hello everyone. In today's video we are going to study about one of the colligative property, relative lowering of vapor pressure. So we have studied what is that colligative property in the earlier video. Please watch that video before studying this topic, relative lowering of vapor pressure. The link of that video is given in the description box. So we will see one of the colligative property, that is relative lowering of vapor pressure. So before studying what is this concept, let us split each and every word and study them. So what is vapor pressure? So to understand about vapor pressure, let me take one container which is having some solvent. Let me represent the solvent particles as like this. And it is closed by using some lid. Now, think that the temperature of this solvent is increased or this is heated. Now, what happens when you heat? The liquid state of this matter, it will change into vapor state. So, it will get converted into vapor and strike the lid of this container or walls of the container and return back, or it condenses back. And at certain stage, the rate of condensation and rate of evaporation, that is the molecules changing from liquid into gaseous state or vapor state, or the molecules changing from vapor to liquid state, that will be equal, and that is called as equilibrium. So whatever the pressure which is exerted by this solvent molecule when it changes into vapor is called as vapor pressure. So when this molecule changes into vapor, it will go and hit the lid of the container. That exerts pressure on the walls of the container as well as the lid, and that pressure it is called as vapor pressure. So that's about the meaning of vapor pressure. Now let us see what is lowering of vapor pressure. So to understand this concept, we will take one example. So this is the beaker which is containing only solvent, and we are going to take one non-volatile solute and add into this solvent. Now when you add solute into solvent, we will get a solution. So I have represented the solvent molecules by using blue color and the solute particles by using the red color. So we have a solution here. So in this case, in case of solvent, as I said earlier, when you heat this, the liquid solvent molecules that will change into vapor state and hit the lid of the container to create some pressure. This will take place very easily because all the molecules are here solvent molecules. But in case of solution, since we have added non-volatile solute into this solvent, non-volatile means this does not volatilizes. Okay, the solid particles they are not volatile, and when you heat this, what happens is the solvent particle, it will undergo evaporation. It should change into vapor state, but not the solute particles. But to change into vapor state and come here, it should overcome the spaces in between these solute particles. So it is not so easy as in case of solvent. In solvent, there is only solvent molecules. It will directly come and change into vapor state. But here, it should overcome the space between that solute particles and then it should come out as vapor. So in this case, in the pure solvent, since the vaporization is very easy, it creates pressure on the lid of the container. Here we can say that vapor pressure is higher in case of solvent. But in case of solution, due to presence of the non-volatile solute, the change of this solvent molecules into vapor is little bit slow compared to solvent. So the vapor pressure also decreases in case of solution. So if I represent vapor pressure of solvent as P, that is pure solvent as P, I can represent vapor pressure of, or I will represent vapor pressure of solvent as P naught, and I will represent vapor pressure of solution as P. So in this case, I can tell vapor pressure of pure solvent, it is always greater than vapor pressure of solution. So this you have to remember, you have to understand this concept before going into relative lowering of vapor pressure. So always remember, vapor pressure of pure solvent is always greater than the vapor pressure of the solution, which is got by adding non-volatile solute into that particular solvent. Why? Why? Because in case of solvent, there is only solvent molecules, it will directly change into vapor state without any difficulty. But in case of solution, it should overcome the solute particles which are present in between and then change into vapor, which is little bit difficult compared to solvent. So vapor pressure decreases. So that's about lowering of vapor pressure. So we can tell that there is lowering of vapor pressure in case of solution when you compare with the pure solvent. Now what is this relative lowering of vapor pressure? As the word tells, here if I want to find out only lowering of vapor pressure, what should I do? We have here vapor pressure of solvent, we have vapor pressure of solution. So which is higher? Obviously vapor pressure of the solvent is higher. So if I want to see how much the vapor pressure has been lowered in case of solution, I can write it as delta P. Delta P is nothing but lowering of vapor pressure. That is delta P, that's equal to P naught minus P. What is P naught? P naught is the vapor pressure of the pure solvent, P is the vapor pressure of the solution. So if you take this difference, you will get some answer that will be the lowering of vapor pressure. Now what is relative lowering of vapor pressure? So relative lowering of vapor pressure, that is nothing but it is the ratio of lowering of vapor pressure to the vapor pressure of the pure solvent. So what is relative lowering of vapor pressure? It is the ratio of lowering of vapor pressure to the vapor pressure of the pure solvent. So that is about relative lowering of vapor pressure. So you have to remember here this formula, relative lowering of vapor pressure. So before knowing relative lowering of vapor pressure, you should be clear about the concept of vapor pressure and lowering of vapor pressure, and also then you can study about relative lowering of vapor pressure. So please remember this one. So that's about relative lowering of vapor pressure. Thank you.